Today we will be looking at scale drawings and scale models. And so a big concept that we're going to be looking at is this idea of scale factor. And that's what it asks in the first set of directions. It asks us to identify what the scale factor is. So what we need to know is, what is this scale factor? Well, basically when we're trying to find the scale factor, we're dealing with two different objects. We're dealing with an actual object and a model. And so it is a ratio of those two objects. And so what we do typically is put the model on top and the actual on the bottom of the fraction. So we're comparing these two. And so when we compare numbers, we either use subtraction or division. And when we're comparing using a scale factor, we're talking about a ratio. And so that's when we're going to use division to compare. And so from here, what we're going to do is we're going to look for which one's the model. Well, the model is going to be the stuffed animal, and the actual is going to be the size of this tiger. And so it says the length is in inches, and so we've got 14 is to 70 inches. And so the inches are going to end up canceling out. You'll see how we have inches over inches, so we don't have to worry about that. So scale factor is not going to have any units. It's just going to have a number, a ratio. And so all we have to do now is take out the common factor. So if you don't see the big number to start with, well, you could start maybe with 2 because they both can be divided by that. And so when we do that, we've got 7 over 35. But then you might see the 7 that goes into it. So if you didn't see 14 at one time, just break it down a little bit at a time, and you'll end up getting to the same point I'm at here, which is 1/5 is the scale factor. So it's done the same way, no matter what the units are, no matter what the type of problem is. Here we're dealing with a dollhouse and an actual house. So again, the scale factor is that ratio of the model compared to the actual. And so we go ahead and take the model, in this case 2 8/10, and I'm comparing it to the actual, which is 39 2/10 feet high. So when we do this, I'm going to go ahead and get rid of this decimal. I'm going to multiply this by 10. It seems like we're going against what we want to do, which is reduce it, but in this case I don't have the decimal to deal with, so it sometimes makes the problem look a little bit easier if you get rid of it. So I moved the decimal over one space, did the same thing in the denominator as well, and that's just multiplying by 10. So when I look at these two numbers, you might say, well, maybe 4 goes into them, because the divisibility rule for 4 is, if the last two digits and 4 goes into, then I know 4 goes into that number. And 4 does go into 92, so let's see how many times. First of all, it goes into 28 7 times, and then 4 goes into 39 9 times, with 3 left over, so that'd be a 32. 4 goes into 32 8 times. Well, there is one more number that we can divide these by, and that is 7. 7's a prime number, and 7 does go into 98. So let's see how many times. 7 goes into 7 one time. 7 goes into 9 one time, with 2 left over. 7 goes into 28 4 times. So there it is, 1/14. That's the scale factor of this dollhouse to the actual house. So now let's use this scale factor in solving for some problems. Solving either for the actual height or the model's height. Well, in the homework tonight, it's always going to ask for the actual height given the model height, or the model itself. And so here it says, on a scale drawing, the school is 1 6/10 feet tall. So on the scale drawing, so that's the model. And so it says that the scale factor is 1/22. Well, we know that 1 represents the model, and then we have 22 represents the actual, because that's how we've been setting up these problems, model to actual. So pretty much that's what we're going to do over here as well. We're going to put the model on top. Well, the model is this 1.6. And what they're asking for is find the height of the school. We don't know the height of the school, so we're going to call this height of school, which is our actual. Why don't we end up calling that equal to A? So there's my number that I'm trying to find. So what I'm going to do is multiply the 1 times the A. I'm going to cross multiply. So when I've got proportions, that's what we're going to use to solve these. So it's 1A, and it equals 22 times by 1.6. So 22 times by 1 6/10. So off to the side, I'll do that 22 times by 1.6. And when I do that, I get 2 times 6 makes the 12. Carry a 1, that makes 12 again, plus 1 makes 13. Add a 0 there and do some multiplication of 1. Well, 1 times a number just makes that number itself, so I'll bring down that 22 and add these numbers together. And I'm getting 352, but I got to move that decimal back one space, so there it is. So the actual height is 35 and 2/10, and let's see what units we should be in, feet. So we'll go with that. So the model's height was in feet, and the actual height is in feet too, and it kind of makes sense, 35 and 2/10. This means it's probably a 2-story building. Or maybe it's just a very tall building, 1-story. Anyhow, it says on a road map, Pennsylvania, the distance from, on a road map of Pennsylvania, the distance from Philadelphia to Washington, D.C. is 6.8 centimeters. So this is the model here. So this is the amount on the map. So we're going to treat that as the model. What is the actual? What is the actual distance between the cities if the scale is 2 centimeters to 40 miles? Alright, so we're going to set that up. Again, it's just going to go this way. Model over actual equals the model over the actual. And so let's start with the first one here, the scale factor, 2 centimeters. 2 centimeters to 40 miles. Now, before I go much further, I can reduce this. If you can reduce the fraction this way, you can't cross cancel because we're not multiplying. But if you can reduce the fraction vertically, then go ahead and do so. It makes the problem easier at the end. So I'm going to go ahead and divide this by 2. I'm going to divide this by 2 to make it a little bit easier to deal with. So let's go ahead and rewrite what we've got now. So now I've got 1 centimeter is to 20 miles. So at times you can end up doing that. In this case, I was able to do it. So let's take a look at our problem. Again, it says 6.8 centimeters. So notice how they're going in the same spot of the fraction as the centimeters was in the scale factor. And we're looking for the actual distance. So we don't know that actual distance. I'll call it A. So now I go ahead and multiply. And so you see how it was easier to reduce the fraction because now I'm dealing with just 1 rather than having to multiply it by 2. So A times 1 makes just A. And I have to multiply 6.8 times 20. So 6.8 multiplied by 20. So maybe off to the side I'll do that. 6.8 times by 20. Well, I'm going to add a 0 because 0 times a number doesn't change anything. So I'm moving over to the next place value and multiply. I get 16. And that makes 13. Move the decimal, 136. So A equals 136 miles between Philadelphia and Washington, D.C. Well, looking at the next one, it says on the scale drawing, a bicycle is 6 4/5 inches tall. So that is the scale drawing. So that's the model. And now it says that the scale factor is 1/6. Okay, cool, we can start with that. And we're going to set that equal to the scale drawing over the actual. But we don't know the actual because it says find the height of the bicycle. So we're going to call that A. Find the actual height. So I go ahead and cross multiply. So you can see how I have A times 1. And then I have 6 times by 6 and 4/5. So we're going to change that 6 and 4/5 to a improper fraction. So when I multiply a whole number by a mixed number, I've got to do that. So now I have 6 times by. And then this makes 30 plus 4 makes 34 over 5. So no cross canceling here. Treat that as 6 over 1. We're just going to have to multiply across. So when I do that, off to the side I'll do 34 times by 6. And when I do that work, I get 24. Carry a 2, so 204 is what I got. So I can rewrite this as 204 over 5. Well, let's just do that division then off to the side. And so we'll do 5 now into 204. Well, 5 goes into 24 times, which makes exactly 20. And so 5 doesn't go into 4, so I'll have to add 0. And I get a remainder of 4. So that makes 40 and 4/5. And this height is in inches. Since they didn't give me different dimensions for the actual, I'll go with the same units as the model. And so on the next problem it says on a road map of New York, the distance between New York City and Albany is 3 inches. Okay, so again, this is the road map dealing with the model here. And then it says that the actual, what is the actual distance? They don't know what the actual distance is. So this is what our variable is going to be. So whatever the question is what the variable is. So it tells us the scale factor. 1 inch is to 50 miles. So 1 inch is to 50 miles. And so we're going to set that equal to the next ratio, and that's going to be the model, which is 3 inches, over the actual, which we don't know, which will be in miles once we solve. And so we go ahead and cross multiply. 1 times A just makes A. And then we have 50 times by 3. So 50 times 3. And so we go ahead and multiply. We've got 150. 5 times 3 makes 15, and add the 0 at the end. So, and this was in miles. So 150 miles between New York City and Albany. Well, those are the types of problems you're going to see on tonight's homework. Good luck.